The purpose of this video is to get you started putting your working data set together, and it may be helpful for us to go back and review a little bit. Now, you may remember this example from an earlier video. We were looking at whether average lifetime income was a cause of the age at death. And we said that in order to look at this, we would first have to measure both lifetime average income and the age at death for every person in our data set. And we said that we would take that information and we would arrange it like this. We would have a row of data for each individual. We would have their lifetime average income and their age at death, and we'd have one row for each person. And then we were going to look at the patterns in the data by moving through each row in our data set to see if there were any patterns in the data. And if we did find those patterns, we talked about these different causal hypotheses that we could use to explain the patterns that we see in the data. Now, hopefully through our work with our DAG, we're going to be able to eliminate this third one or minimize it, this confounding, leaving only these first two causal hypotheses to explain the associations that we see in the data. But if we go back to my DAG here in Dagity, we can begin thinking about what actual variables I'm going to need for the model that I want to build. And here you remember that my model is going to be looking at the years of smoking as a cause of the FEV1 to FVC ratio. And here is the DAG that I showed in an earlier video. So one difference is that here, where before I had socioeconomic status, I've split this into two variables, income and education. And the reason I could use a single variable before was because the arrows coming from income and education, both going out and coming into them, are exactly the same. So before I could use a shorthand version, just a single variable called socioeconomic status for these two variables. But here I'm now splitting them out so that we can see them more explicitly. Now you remember Dagity tells us up here which variables we need to control in the analysis in order to control for the confounding between our exposure variable and our outcome variable. And it's telling me that I need to control for or condition on age, education, income, race, and sex. So let's go ahead and do that conditioning. And we can see that all of the red lines go away. And so by conditioning on these five variables, we have controlled for confounding between years of smoking and the FEV1 to FVC ratio under the assumption that our DAG is correct. Now, I had another model which has years of smoking as the exposure, but chronic obstructive pulmonary disease as the outcome. This is going to be my model with the binary outcome. And because the FEV1 to FVC ratio and COPD are so closely aligned with each other, COPD is really just an extreme version of airway constriction. The DAG around the variables in both models I have are exactly the same. And so I will need to condition on exactly the same variables in both models. So let's just look at the FEV1 to FVC ratio model as an example. Now, what variables do I need to bring into my model? Well, I need, of course, something to represent the years of smoking, and I need the FEV1 to FVC ratio. Other than that, what I need are only the variables that I am going to condition in the model. So age, education, income, race, and sex. These other variables in my model, air pollution, childhood respiratory infections, occupational dust and fumes, these genetic markers, and even height, are not necessary to be in my model. So I don't need to bring those variables into my working data set. So it might be helpful for us to see the target at which we're aiming for our working data. So if we look here, this is a representation of what my working data might look like for my COPD model. And over here on the left side, I have some variable which represents the subject study ID number, numbers 1, 2, 3, 4, 5, 6, 7, 8, etc. And I have a variable which indicates whether or not the participant has COPD, and then years of smoking, their age, their education, their income, their race, and their sex. And these lines indicate data points that we would have for each of these variables for all of the people. So this row represents the data for one person. In this case, subject number 1, their COPD, smoking age, education, income, race, and sex. Now, let's just look at one individual's data to make it simpler. Now, one thing that we should recognize is that these data exist in different data sets within the NHANES website. So for example, my information on COPD is in the spirometry data set. I'm also going to be using some information about medical conditions, more on that later. The smoking data are in the smoking data set, and the other variables are in the demographic data set. Let's take a look at the NHANES website to see what I mean. So if we look at the NHANES website and we click on questionnaires, data sets, and related documentation, and then I'm using the 2007 and 8 and the 2009 and 2010 data. If I click on these, then we see here there's the demographics data, the dietary data, the examination data, lab data, questionnaire data, and then limited access data, which we actually can't use. And so if we go into the demographics data, and you remember that you click on the .doc file, then you can find the information about all the different variables. And here, for example, here is the sex variable. They call it gender. So it's RIAGENDER. And you can see that males are coded 1, females are coded 2, and missing values are coded with a dot. And you can see the sample sizes here. And some of the other variables that I need are here. Here is age. I can use age in months at the examination. Here is race, ethnicity. Farther down here, I have the education level of adults 20 and above. That's the age group that I'm using. And then for income, I can decide if I'm going to be using the annual household income, the annual family income, or the ratio of the family income to poverty. I have to make a decision about that. Now, if I go back, I also have some data in the examination data. So inside the examination data, I'm going to be using data from the spirometry testing. It's in this data set here, SPX_E, and different variables that I need are going to be in here. So the point here is that the data that we need are split up into different data sets inside the NHANES website. So for my data, the different data sets that contain the variables I need are represented up here at the top. Now, in addition to having data that are contained in multiple data files, we are also combining two different cycles. So for me, I'm combining the 2007 to 2008 cycle data with the 2009 to 2010 cycle data. So we're going to be doing a couple of things here. We're going to be within each cycle, and for within individuals, we're going to be connecting the data together from the different data sets that are contained within each cycle. And we're going to do that within both of the cycles we're looking at, and then we're going to just group all of the data together. So we want to get started, and the first step is that you need to choose the variables from the data sets that you're going to use in your models. And you're going to need the variable or variables that you need to construct your exposure measure, your outcome measure, and then all of your conditioned variables. Now, one of the things we need to pay attention to is that because we're going to be stacking these data from two different cycles, we need to make sure that the variable names in each cycle match each other, and also the way that the variables were coded, the way the information was encoded in each of the variables is consistent across the different cycles that we're going to be using. And if we find that they are different, we're going to have to change them so that they're the same. Now, in most cases, probably you're going to find that the variable names and the coding are both consistent across different cycles of the NHANES. They're pretty careful to keep things consistent across different cycles, but sometimes we might find some differences. And so we just have to verify that everything is the same, or change things if it's different. So to do this checking for my model, I've created this Excel file, and I want you to create the same Excel file for your analysis. And you will have this Excel file that I've created, and you can just copy my format. You can just erase my variables out of it and put your own variables inside. So let me just show you what it has inside. So if you remember, I'm using the 2007, 2008, and 2009, 2010 data. And I've colored all of the information about the 2007, 2008 data in green, and the 2009, 2010 is in white. And there's different kinds of information in here. Over here on the left side, what I've done is I've listed every variable that I think I'm going to want to use in my model. And it doesn't matter if I forget a few at this stage. We can always add more variables in later. But these are the variables that I can think of that I will potentially be using. And so what I'm doing is I am, for each variable, I am going to the 2007, 2008 data, writing down the variable name, and also writing down how it is coded. And I'm doing that for the 2009 and 2010 data as well. And so I can very easily compare the two to make sure that the variable names are the same and also that the coding is the same. Now, let's look at a different one as an example. Let's see, what should we use? Let's use this one down here. The question is, did you smoke at least 100 cigarettes in your lifetime? And it's coded 1 for yes, 2 for no, 7 for refused, 9 for don't know, and a dot for missing. Well, where did that information come from? Well, I found that information inside the NHANES website, and these data come from the questionnaire data. I'm in the 2007 and 2008 data now. And it's inside the smoking cigarette use data set. So if I look at this, so where is the variable? Here it is right here. So did you smoke at least 100 cigarettes in your life? Here is the same information that I used in the Excel spreadsheet. So you can see that I've just copied that information. And then I went over to the 2009 and 2010 data. And I checked the same variable here. And you can see that the variable name and the coding is exactly the same. And so I did that for all of the variables that I'm going to use. Now, one thing you also want to keep track of are the data set names that you're going to need to include to get your data. And so, for example, for the smoking variable that we just looked at, it was in the data files SMQ-E for the 2007 and 2008 data, and SMQ-F for the 2009-2010 data. So if we go back here to the 2009-2010 data, we can find that the name of the data set is right here in the .doc file. So you just want to keep track of those. And the final thing you want to keep track of are when were the data collected. And there are two primary points where data are collected in the NHANES. One is the interview that happens in the household. The second place is the mobile examination center. And what happens is that some people who are interviewed in the household don't go to the mobile examination center. And it turns out that that's going to be important information later on. We'll learn why that's important later. But now we just want to record if in these two columns, if the data were collected in the mobile examination center or if they were collected during the household interview. And then we also want to indicate the subset of people in the NHANES data set that had that variable information collected. So here all means that everybody who had the interview had their race ethnicity value indicated in the data. But up here, for example, for this one, the baseline force vital capacity quality attribute, this was collected in the mobile examination center for people aged 6 to 79 years. And you can find that information by looking up here in the information in the .doc file. It will tell you, if you look in the eligible sample, here it says all survey participants 12 years and older were eligible. So this is where you can find this information that I am encoding here. So what I want you to do is I want you to create this Excel file for your particular model. And at this point, don't worry if the variable names turn out to be different or if the coding turns out to be different. We'll fix those things at a later stage. What's important at this point is that you get as many of the variables you need as possible into this data set. And don't worry if you miss a few, we can add them later. But you need your exposure variable, and you might have more than one variable that you're going to use to construct your exposure measure, your outcome variable, and also all of your conditioning variables. And put them into this Excel file and bring that with you to our next class session.